Yes, so we're confusing you all about Roombas and vacuum cleaners. This is more about unleashing cognitive computing on the masses. And here to share their thoughts and get into a lively discussion is Arijit Sengupta, founder and CEO of BeyondCore, and Laura Haas, who is an IBM fellow and director of the Accelerated Discovery Lab at IBM Research. Over to you, Arijit.
Hi, everyone. We are not just talking about vacuum cleaners. The basic idea is what is cognitive computing and why do you care, right? So actually, maybe we should do quick introductions. Would you like to start?
Sure. I'm Laura Haas. I've worked with IBM Research for most of my career, most of it right out of San Jose, down south. I'm a data person. I have done a lot of work over the years in bringing together very different and disparate kinds of data. What I do right now is I run a research lab for IBM on accelerating discovery, which is about how do I help people get more information out of data faster than they can today. And we look at all aspects of that problem, from the technologies all the way to the social collaborative facilities that you can provide to help people make progress faster.
I'm Arijit Sengupta, CEO and founder of BeyondCore. My background is computer science and economics from Stanford, MBA from Harvard, dance minor in the middle there somewhere. So pretty much a recovering nerd, if you will. And what BeyondCore is focused on is how do you bring the power of advanced analytics to every business user? What we mean by that is you should be able to just ask a question like, what's driving my revenue, or what's causing patients to stay longer at my hospital, and have the computer tell you exactly why. That's what we are focused on, and we have been doing it for 21 of the Fortune 100 in the last year, so it's been a fun time. To start off this thing, what the heck is cognitive computing, and how is it different from, self-service BI, data warehousing? What are we talking about?
So, yeah, I'm a data person, so first of all, I have to say up front that I do believe that data is fundamental to cognitive computing, so please don't get upset by anything I say after this, because obviously the next statement is none of the tools that you're used to using today are cognitive computing. Cognitive computing is about systems that learn from data. So the data doesn't just sit there. They haven't been pre-programmed with all the rules for how to go do some analysis on it. The system has to learn from the data, and as more data comes in, get smarter and smarter. So that's part one. The next thing I'd say about cognitive computing is that it's about having systems that can interact with people in very natural sorts of ways. So using the kinds of technologies that we most like speech, like natural language, by having the ability perhaps to see and react to things, or to present materials visually that will help us understand and work with them. And why is that important? What's, I think, the final thing that I would say about cognitive computing that differentiates it from most of the technologies that we're used to is the purpose is actually to extend the capabilities of the individual and ensure that, in fact, both the individual and the machine can do better working together, than they could individually. And so it becomes very important that the computer can not only learn as you're learning, but can interact with you in a good way, so that it can assist you in doing better and doing more than you could by yourself.
So take a line from the Supreme Court. I think cognitive computing is a little bit like pornography. You know it when you see it. So we had the CIO of a Fortune 100 in our office, and he's playing with BeyondCore, and he says, and I can see his body language, right? His body language is very constrained. And he turns to me and says, Arijit, I just figured out what the problem is. Now, being a startup, you don't want to hear a CIO saying problem, right? Especially Fortune 100. I said, yes, sir, what's the problem? He said, I'm not telling this darn software what to do. It's doing things on its own. I've never seen that. That's cognitive computing, right? So I can't tell you how to define cognitive computing, but when you have that moment of, what the heck just happened here? That's when you know it's cognitive computing. And I love the tool thing you said. We actually have a jar in our office, anytime they use the word tool, they have to put $1 in there because that's a definite difference, right? It's a Roomba, not a vacuum cleaner. It does things on its own.
Yep.
Now I tied it back to your question. Please continue. So anything you would like to add to that?
No, actually,
Okay.
it's great.
So why should we care? How is this going to change our lives? Is this just yet another technology that we are going to spend lots of money on, or does this matter?
I think it's going to matter. I think it's going to change the world over the next 5 to 10 years. I think we're going to see a very different way of interacting with the computers, for lack of a better term, that we've learned to depend on, where it will become a much more positive sort of thing. So let me give you some examples. We have billions of people on planet Earth. No two of them are alike. We know enough about medicine these days to know that you and I could come down with the same disease, and because of who we are, our genetics, what we've done in our lives, our social behaviors and so on, we are going to have very different responses to the same treatment. And different kinds of treatments will be more effective for one of us than the other. But there are billions of people on the planet, so although there's probably nobody else exactly like me out there, it is possible that there is a good-sized cohort of people who are enough like me in key characteristics that if I know how they've responded to different treatments, that can make me, the doctor, more effective at treating me so that I'm no longer sick. So that's the kind of things that I think we'll start to see. One of my other favorites would be personalized education. Today we've watched generations of children struggle. Some do very well with one set of techniques, others with another. Imagine that they each have an assistant sitting next to them who's learning how they learn as they learn, and can then start to tailor the materials to them so that they can learn faster and more effectively. Imagine what a difference that would make to planet Earth if we could really educate all of our children in the most effective way that we can. So those are two that I like.
So to extend that a little further to, for example, you talked about earlier about figuring out what's important in the data. So healthcare example, we were looking at 30 million patient lives with McKinsey, and one of the patterns was young women with diabetes had a 49% rehospitalization rate. Young men were not as bad, but they also had a higher rate. Anyone wants to take a guess why young women with diabetes might have a 49% rehospitalization rate out of 30 million patients? Go for it. Actually, not pregnancy, because young men also went up a little bit, and hopefully they didn't get pregnant. But it could have been sympathetic pregnancy, I guess. Anybody wants to take a guess?
They were working and their lifestyle was
Not really. Actually, it turns out when you don't take insulin, you lose weight. So it was a weight loss strategy. Young women were trying to lose weight by not taking insulin. But when you go to that same woman and you say you have a 49% chance of getting your foot cut off, losing weight looks like a much smaller problem, right? But you couldn't find something like that without cognitive computing, because you would have had to think of a question like young women with diabetic ketoacidosis. There are millions of such questions. That's how big data analytics and cognitive computing can get very specific. Does that work? Please. Well, we'll take that offline a little bit, but basically, one of the interesting things about cognitive computing is you can look at very large variables. Actually, I should let you answer that. I'm sorry.
It's about learning from the data, and any of these medical or educational examples, any of these things where you have millions or billions of individuals with many, many thousands of variables distinguishing them, humans can't learn from all of that data. We can't take it in. So a very trained specialist might think to ask the exact right question, but in fact, you have to then have the individual in front of that right specialist at the right time, whereas a cognitive system could start to, as it starts to see more data, may start to see the variables that are in common across them and be able to synthesize the question, in essence, for you so that you can then provide a solution.
Please. I'll repeat it. Go ahead.
The technology is racing ahead, but it sounds like the theme in most of these conferences is the human systems are not catching up to where the technology is. So it's not a question of what's accomplishable, it's how do you get the work structures, how do you get people trained? Given the human structures that we have today, and that the topic is unleashing cognitive computing, how will you train billions of people to be able to work with augmented intelligence in a way that's different than they're being trained today, since that's going to be a major impediment to...
I love this question. Why don't you go first, and I'll take the next one.
That's a brilliant question. It's actually...
Oh, the question was, how do you transform the people so that they can start leveraging, benefiting from these technologies? Because you can't train the people, you can't use technology. Quick summary?
Yep. So I will take you back to the sort of three-pronged definition I gave and say that one of the things that differentiates cognitive computing is it needs to be able to interact with you in ways that are natural to you. So if cognitive computing is successful, in fact, if you have a real cognitive system, it's easier to use. You don't have to be an all-star programmer. You don't have to be able to, deal with cool visualizations that maybe confuse the heck out of you. I'm not a visual person. The system will be trying to interact with you in a way that you're more comfortable with. So that's part of it. Now, that's not where we are today. Okay, I'll be really honest with you there. We have a long way to go, and so, if you ask me how are we going to get there, it's not so much about training the people as about building more and more sophisticated cognitive systems. And I think there's a lot of places we can go there to make it possible for those who have to program the systems, that is the application developers, if you will, to write more powerful programs more easily. And so that's the part of the question that I think is really interesting, is how do we get the next SQL? How do we do for cognitive computing what SQL did for databases? How do we get to the point where those who are building the applications can move faster and train?
We'll get to that. Just let's finish up this with question really quickly.
Go ahead.
So I will disagree with you. I was told I need to disagree with her at least once, and it's going to be easy this time. Firstly, I think this technology is already here. You just need to know. But the second part, the crucial part of what you said is, a lot of people are thinking about how do I take a data scientist and make them 100 times more effective, okay? So what you're really saying is, out of all the people in my company, I'm gonna take 1 out of 1,000 people, make them step forward 100 steps, right? What happens? You open up a huge chasm between the people who have been empowered by your technology and the rest of the group, right? What you really want to do is, how do I take everybody in my company and have them move up 1, 2, 3 steps forward? Some of them will move up 50, 60 steps, but how do we move everyone? Because if you can't do that, you cannot have impact. And that is where I get excited about cognitive computing. I was going to ask you about acid tests, so I'm going to go a little early on this. The goal I set for my team was, in 5 minutes, can a user who has never seen the product be able to use it? If they can't do it in 5 minutes, it's not cognitive computing. Should we move to the acid test?
I don't actually disagree with that. I mean, as far as I'm concerned, it should be very easy to use because you're not really using it. You're collaborating with it, right? It's all about the collaboration between human and machine. So, yeah, acid test, does it learn? If it's programmed once and it does just what it does, it's not cognitive. Does it interact with you in a collaborative way that helps you move forward, whoever you are, whatever your job is, as long as it's somewhat relative to what it's trying to do? Fine, that's good, right? And is it helping you be effective in the world? And those are what I would point to as my acid test. We've been telling, they're telling us we're out of time.
Yeah, we are almost out of time. So
you can come and
we'll continue it offline. So to continue with, just to finish off on the acid test idea, the key thing I would say is, think of an iPad and a child. 3-year-old child can start using an iPad, right? That's where we want to drive. The technology should be so designed around the human that it's not an effort to understand the technology. That's, I think, the closest summary I can give. Okay, we are out of time.
But iPads are not cognitive computing.
Yeah, they're not. iPads are not. Thank you.